Good day, grade 10s. In this video, we are going to, on vectors and basically vectors, we are going to discuss the basics on the addition of vectors. First of all, it is important to understand positive and negative vectors. When vectors are acting in the same direction, the angle between them is 0 degrees. And the direction of those vectors would be taken as the positive direction. On page 195, there is an example where Ibrahim pulls a crate with a force of 20 newtons to the right. So this is a relative direction. So we've got a crate, and I'm going to draw a force diagram now. So he pulls a crate to the right with a force of, and I'm using a little I, Fi, force of Ibrahim, 20 newtons. Rafat sees that his friend is struggling and so helps by pulling with a force of 50 newtons to the right. So he joins and he pulls with a force of 50 newtons. Now these forces are acting in the same direction. So the angle between these forces, that angle theta there, is 0 degrees. Now when the forces are acting in the same direction, we choose that direction as the positive direction. So if we want to get the resultant of the forces, or the net force, algebraically we can say it is the force of Ibrahim plus the force of Rafat. So that takes us to 20 newtons plus 50 newtons, and that gives us an overall force, the resultant force of 70 newtons. I'm jumping ahead here with my explanation. So when forces act in the same direction, they form the biggest possible effect on the object, 70 newtons, which is called the net force. So their father could come along and pull with a force of 70 newtons and have the same effect. That is what net means. When forces act in opposite directions, the angle between them is 180 degrees, and the one direction is taken as positive, while the other direction is taken as negative. And I want to look at the example on page 195 again. Nazli pushes a trolley in a supermarket with a force of 100 newtons. So here we go. Got a trolley there. And she pushes. The force of Nazli is 100 newtons to the right. Her friend Jody pushes against the trolley in the opposite direction with a force of 60 newtons. So the force of Jody is 60 newtons in the opposite direction. Now we need to decide, because these forces are in opposite direction, we need to decide a positive direction, then the opposite direction would be the negative. Now I'm going to choose the bigger one as my positive direction. So this one in that direction is positive. That means that in this opposite direction, that would be a negative direction. When we add these forces algebraically, because the angle between them, if I tie the tables of the forces, 60 newtons in that direction and 100 newtons in that direction, it is easier to see that the angle between the two forces is 180 degrees. So the net force in this effect would be positive 100 minus 60, so that would be 40 newtons. So Nasli could just as well have pushed with a force of 40 newtons and have the same effect on the trolley. This, deciding which direction is positive and which is negative, will play a very important role in your physics career. Right, with the addition of vectors in the same direction on page 195, the first example, you have Ibrahim pulling a crate with a force of 20 newtons to the right, and Rafat sees that his friend is struggling and he helps him by pulling with a force of 50 newtons to the right. What is the net resultant force? Now, to use the graphic method, we need a scale. Now, it seems like a scale of 1 centimeter to 20 newtons will be suitable in this case. Now, it's always good to draw a rough diagram, and I'm going to draw it here. So you've got a force of Ibrahim, Fi, and that is 20 newtons to the right, and the force of Rafat is 50 newtons to the right, so Fr is 50 newtons to the right. So I need to start somewhere. Now 20 newtons would be 1 centimeter long if I use that scale. So there I have my F1. Now your arrows may not, your arrow may not make the line longer or shorter. So my arrow is a little bit inaccurate there. There you go. Now we add Rafat's force to the tail of Rafat's force to the head of Ibrahim's force. So we go, and that line will be 2.5 centimeters long. So 2.5. That brings me to 50 newtons. Now, to get the resultant of the two forces, we need to start at the tail of the first force and end at the head of the second force. So you do that, and if you measure this line, it will be 3.5 centimeters, and that represents 70 newtons. So F net is 70 newtons. For vectors in opposite directions, we draw the situation on page 195, example 1.6.2. Nasli pushes a trolley in the supermarket with a force of 100 newtons. So here's her trolley, and she pushes Fn for Nasli with a force of 100 newtons. Then her friend Jody pushes against the trolley in the opposite direction with a force of 60 newtons. So the force of Jody is 60 newtons to the left. Right, so if we're going to solve this problem graphically, we need to choose a scale. A suitable scale in this case would also be 1 centimeter to 20 newtons. And it's always good to draw a free body diagram where we join the forces by the dot, the tails by the dots, at the dot, sorry. Fj would be 60 to the left and Fn would be 100 to the right. So 100 to the right would mean that that line is 5 centimeters long. Right. So this is my 100 newtons to the right. Now to the head of this 100 newtons to the right, I'm going to add the tail of the 60 newton to the left. So 60 newtons to the left will be 3 centimeters long. Newtons. So the resultant force would be from the start of your first vector to the end of your second vector. So that means this line here is my net force, and it is 40 newtons to the right. Sorry, in the first example, it's the resultant is 70 newtons to the right. So what I've done is the head to tail addition of vectors. That's what I've demonstrated in this diagram. I think I'm going to cut down on the example. So it's a graphical method of adding vectors where we use the scale and we add the arrowhead of the vector to the start, the tail of another vector. The resultant vector is a very important definition. It is the single vector that will have the same effect as two or more vectors acting together. Now I want to discuss change in vector. When we calculate resultant, we add vectors, whether they are positive vectors or negative vectors, that we add them. When we calculate the change in a vector, we will always take the final vector and subtract from it the initial vector. And I will discuss examples like this in the next video. Thank you for watching.